Okay, let's get into some code. This lesson is all about the hands-on. We've covered the principles, and now it's time to start implementing our code. We're going to focus on two mechanisms for the lab today. The first is how to implement a role chain in code, and the second is how to test our Lambda function in the console and work through error messages. Now, let's quickly cover each of these, and then we're going to just get into the meat of the lab. Now, as a reminder, a role chain is when you use one role to assume another role. In our last lab, we learned how to define the permissions to secure a role chain on both sides. Now, with that out of the way, everything is in place to assume the role. Now, this isn't the first time you've role chained. In previous labs, when we logged into the IAM Identity Center and then used the little switch role link in the upper right corner of the console, that was technically role chaining from our Identity Center role into the organization account access role in whatever the target account was. But stuff in the console is kind of like magic and abstracted, and now we're going to get to see the guts. The trick when writing this in code is that you are creating a session. And you can code in multiple sessions and pick which one you want to use when making an API call. Heck, you can set up like 8 different sessions and go all doc-awk and do different things in different accounts simultaneously. That's something I actually do all the time. Now, before we get into how this works, we need to actually spend a little bit of time talking about how API calls in AWS work. Because I use the term session a lot, and sometimes in the console and code, it looks like there's some kind of secure pipe we're making all of our API calls through, but that's not actually how it works. You see, when AWS was created, SSL hardware that worked on the scale of even then baby AWS was really expensive and not viable for the volume of API calls required to use public cloud. And so to keep AWS API calls secure and private, Amazon just built all the encryption into the request itself. So when you make an API call in AWS, it uses something called HTTP request signing with the signature for algorithm. The API call itself is a self-contained encrypted blob that uses your access key and your secret access key. Think of this more as it's a secure envelope with encrypted letters going from point A to point B through the mail, and it's not like a continuously encrypted pipe like an encrypted phone call. That way they didn't have to use all those SSL connections. You could send something as plain text, but it would still be protected because it's an encrypted object running across the internet and there's nothing anybody could do with it. All right, so with that out of the way, let's talk about how we're going to work this today in our code. Now, you always need to start with the base identity. And in our case, that's the default Lambda execution role that we set up when we first built our Lambda function. If we assign a role to a Lambda function, the service just uses that role. It automatically will assume that role for us when our function runs. And any API calls that don't specify using some sort of a different session will by default use that Lambda execution role that's established in the console, or if we were doing this via command line or API, established that way. Now, after that, we need to manually assume roles in our code. And that's what we're going to see today. So assuming a role, all it does is it retrieves temporary credentials that we use to make those API calls. Remember, an API call is that encrypted letter, and the assume role gives us the credentials we need to encrypt our letter. So let's go to the screen, and I'm going to walk you through the function in our code that we use to assume a role into another account. Now, since we're using this to assume into multiple accounts, but the role name is always going to be the same, but the account ID is going to be different. So I'm actually going to show you how our little Lambda function just takes the account ID of what account we're going to jump into. And it actually, when we write the code, you'll see it pulls that account ID from the event bridge event that is actually triggering the Lambda function. So it's pretty cool how this all works. All right, let's switch over to the console here, and let me get my little whiteboard up and running and make sure the connection is working. Whoops. It helps to get the Apple Pencil that is the correct one and use that one to log in. Log in? Did I say log in? Use that one to actually go ahead and do our whiteboard. This is the function that we're going to use to actually assume the role. So we can call this from multiple places in our code, and this is going to do our role assumption for us. Now, this has that assumption that we have the security auto remediation role. So the first bit of code that we have in place here, and if you go into the blog post, I've got this in a little bit cleaner bit of a diagram, but basically this is taking that account ID, and when you call this function, you pass in the account ID, and we do this by pulling that from the actual EventBridge event, and this is going to create a variable called role_ARN, and you notice the only thing it's substituting in is that account ID, and the rest of the path is hard-coded here because we use, stack sets, and we always know what the name of that role is going to be. So that's step one, is we have to set up that role ARN. Now, the next thing we need to do is over here, and this is, and let me go ahead and adjust my centering here. STS client is going to be, so Boto3 is the software development kit library we use in Python for Amazon Web Services. So everything you'll always see is Boto3. And the first thing we need to do is connect with that STS service. Now, that's going to be using that Lambda execution role that we already established and built. Remember, that role lives in this account. That's automatically assigned. The Lambda function has that role. So this is, I'm going to call it our anchor. Does that, that's a J. That's not an anchor. Is that an anchor? I don't know. Whatever. I'm bad at drawing. Oh, wait, maybe the anchor has a little bit at the top there. And now I just lost all of you. We've got our anchor role, which is that Lambda execution role. And that's what we're able to use for the rest of the building out our role chain. Then this is the beef. So right in here, the first part of this says we are going to assume the role. We're doing that API call. It's using this base role that we already set up. And then it's saying, assume the role with the role ARN. So that gets fed in there. And then we're establishing a session name. And anytime you do an assume role, you always have to have a session name. So we're using one that makes sense for what we're doing. Now, the result of that is in this thing called a response object. And from that response object, we are pulling the credentials out. And those credentials, as you can see here, are the access key, the secret key, and the session token. So those are the three things we need. So the access key, the secret access key, and the session token. So what have we actually done here in all of this code? We have basically said, one, let's go ahead and get the ARN of what we want to assume, because that account ID is changing, but the rest of it's going to be the same. Two, we're going to connect to the security token service using our Lambda execution role. And sorry for the acronyms, but it's the only way to fit it all on the screen here. And then three is we do the assume role. And the role we want to assume is that ARN, and we're using those credentials. That assume role returns our credentials. It gives us some other stuff, but essentially it gives us those credentials, which are the access key, the secret access key, and the security token. And then we take those and we're just basically embedding them into an object called credentials. And oops, let me switch to my drawing here instead of the erasing here. And then that variable, that object, is called credentials, and that has that access key, the secret access key. So now we have a way to refer to this moving forward. So this is the key point. Assuming a role retrieves temporary credentials that we will use to make API calls. We still have credentials, but they are ephemeral. Because the idea of, this is where it gets a little bit tricky because of this whole idea of a session. The process we just did gives us those temporary credentials. But then we need to create something called the actual session to work with. So a session in Python. So remember, there's the concept of a session when we get our session key or our session token. That is, these credentials, that access key, the secret key, and the token will work together for a default of 1 hour. Now, we're creating something called a session in the code. I'm going to show you what that looks like in just a moment here. But it is the container or the object in the code that we use that holds the credentials, the region, and any other configuration options. We're not messing with those today, but there will be other times in code where we might actually set a session for a particular region, or we can actually, later I'm going to show you how to insert a session policy that restricts our permissions. And so that object, that session object, is what we use to make the API calls. So it's not that this function that I'm about to show you reconnects with AWS. All we're saying is create a session object that stores the credentials so I can use them for all my other API calls. And remember that a session on the AWS side is just a set of credentials that expire, and it's not some kind of a persistent pipe. So you see my eyeballs changing as I was scrolling down so I can actually show you what this looks like. But the session object in Boto 3, it's just the container so that we don't have to manually insert the access key, the secret access key, and the token every time we make an API call. We just say, use those three things that are in this session. This is what it looks like on the screen. And let me scroll down over here to show you. So in our code, we have this, how do we actually create that session object I talked about? And all we say is, so the credentials, first thing we're going to do is we call our assume role function, which is the one sitting up here that I showed you before. So that's going to assume the role. That function returns those credentials, which are now in that little credentials object, that variable there. Then session equals the Boto 3 command to create a session, and then use those credentials. And so from that point on, I can refer to session. And when I refer to session, that's just an object that has the access key, the secret access key, and that security token. So I don't need to punch those in every time. And so we can now write an API call that would look something along the lines of, let's say, let me actually go ahead and look at the code again. And so if we wanted to make a connection to S3, we could call it, S3 connection. And then that would be equal to, and then we use that Boto 3 dot session, or sorry, Boto 3 dot client. Whoops, sorry, not Boto 3. I am already messing up my code here. Apologies for that. We actually say session dot client S3. There'd be quotes around that, but my handwriting is terrible. And this line says, use this session stuff, create a new S3 client, and then we could say, that S3 underscore connection. I mean, usually we call it S3 dot client, then dot, I don't know, list underscore buckets, or whatever that API call is. I know this is a little bit confusing if you haven't worked with the code before, but I want to try and simplify it as the best time, or in the best way that I can. We have our credentials now in this little object that we can use for API calls. And that object, we called it session. We don't have to call it session. We could call it session 2, session 3. We could call it whatever we wanted to call it. And then Boto 3 understands, use those credentials to create that S3 client. And the client is, now I'm going to make that, it basically says that when I make the API call, create that encrypted letter and send it off to the S3 service. And a bunch of that stuff is just all built into that software development kit. So, look, this is one of those situations where I don't want to overly complicate, and I also don't want to overly simplify. It's a very elegant system, especially once you get into the weeds and you see how AWS processes all these API calls on the back end. There's crazy stuff like service and region and daily keys that get involved. And these requests aren't just decrypted and spread around on the back end in plain text. They're actually used as encrypted objects everywhere within the back end of AWS, which is why all these keys and everything are so important. So I want to just review it one last time to try and keep it simple. We start with our base identity. Otherwise, we can't even talk to the security token service to assume a role. And we saw all the security stuff, and you can review last week to remind yourself how that part works. Then we make the assume role API call. That's going to return a set of temporary credentials that will be usable until they expire. We didn't call that a session. Then in Boto 3, we use which is the software development kit for Python, we use the boto3.session command to create a reusable object in our code that holds those credentials, so it makes it easier to use them. Because otherwise, every time we go to make an API call, we'd have to say, make the API call with all of these keys. So that's why they call it a session, because it's only going to work until those credentials expire, and then we would have to create a new session. But again, it's overloading of the word session, and that's the part that gets confusing. And the cool thing is when they do expire, we just need to renew them, and then everywhere in our code that would work. We're not having to like repass in access key and secret key as individual strings of text. Then that session.client, and then in the service name like S3, that's what sets us up to make the actual API calls to a service. And when we make the API call, when we write down our code, all it does is it takes that API call, that request, and it does all the encryption on it. It makes that encrypted letter and then sends it off into the mail to the right part of AWS. And in our code, we only have that one called session, but you could write different ones like session _logs or session database or session let's break things. All right. Explaining all that is already longer than I planned. And I did say we're going to cover two things, which is about testing our Lambda functions. And this part's really quick because to test a Lambda function, there's the I'm a real developer way of doing things, and then I'm a hacker security person who just slaps stuff together option. I think you've all known me long enough now to know which of those that I am. Yeah, we're going with the latter. If you're doing full-time development work and big project work, you're going to want to use something called a local testing framework, local stack, or the AWS SAM CLI. I'm not even going to describe what those are. I don't even link to them. I'm just going to name them. But that allows you to actually do and test a bunch of stuff locally. For our purposes, we're going to run our tests in the console using a built-in capability in the console to do that. Now, in the last lab, we actually logged into an account and we made changes and we went to see if that would actually trigger our function because we needed to test everything end to end. This week, all we need to do is test that our code works properly once it gets an event. And so we're going to do that in the console with something called test events, which allows us, we're actually going to generate another event the old-fashioned way, log into the account, make a change to the S3 bucket, grab that event, and then we're going to pull that JSON, we're going to paste it in, and then we just reuse that over and over and over again to actually test our code. So that's a much more efficient way to do it, and that's what we're going to do. So in the lab, we're going to get started by generating that event because we need that test event, and then we'll go ahead and we'll actually build out our Lambda function. First thing we need to do is jump into that production account so that we can generate our test event. So go to Cloud S.L.A.W and Administrator Access. Now, here you can do one of two things. As you've seen, this should be on your pick list from your role history. Remember, that is that production one account. If you don't have that in your role history, you can just go to Organizations. And within Organizations, go down to your, workloads, prod, and get the account ID right there. So because we're in our management account, it's available right there. And then copy that. And from there, go to switch role and enter that information in. Now I'm going to cheat. And actually, you know what? I'll actually go through the process again this time. So let me match the color there. So I will copy it. Okay. Copy, because we haven't done this in a couple of weeks. And we'll go to switch role. Put in the account ID. I use the account ID as the display name, so we'll leave that there as well. And it's the organization account access role. And then pick the display color, whatever you want that to be. So switch role. And this is going to get error because I'm still in the organizations, but you can see I'm in that account now. And we'll just go to S3 because we have our one bucket. Click on the bucket. Click on properties. And then you can see I've been doing testing with various tags here. So click on edit and add tag, and it doesn't really matter what it is. And I will save changes. and that is generating the event. At this point, I can close this window. Now, that event is going to show up in my email box. So let me go ahead and I'm going to pause the video while I grab that from my inbox. That showed up in my inbox pretty much immediately. And the reason I'm pulling it up as the actual email is so you can see how I copy and paste this out. So again, we're going to use this as our test event. So I need to copy everything within that section there. So I'll copy that and I'm going to paste it into my window here. So what you don't want is you do not want the full email. You don't want any of this or any extra spaces, everything there. And in my case, if I just click on this, because I'm in a text editor that understands JSON, I can go to JSON and it goes ahead and whoops, it moved everything onto one line because it was continuous and did all the code stuff on it. So let me go back and leave that and paste it back in. Oh, now I'm stuck with that. Anyway, it's ugly, but it's still going to work. Okay, so I'm closed out of that account. And I don't need to be, remember we did that switch role function, which is basically from the role that we're in here, we went in as administrator access. So that was an admin access role. And then I used that to switch a role. So that was actually role chaining right then and there. Okay. Now into security operations, and we'll go in with either admin or security admin access. And within our security operations account, we're going to go in so we can start playing with our Lambda function. So I'll go to Lambda and our security auto S3 function, which is right here. And remember, the trigger destination stuff doesn't show up just because of how we're doing cross-account things. Now, just as a reminder, if you go into configuration and you go to permissions, you can actually see the role that we're using, the security auto S3 role, and you can see some of the permissions and the statements that we have there. But we don't care about that. We're going to go into the code, and I actually want to, go into test. So what we're going to do first is we're going to make our test event. So I go into test, and we're going to make it as, let's just call it S3 test for our test event name. This is not going to be shared test event. It's just going to be exist in this account. And all I do is I copy that and I paste in. And if I click format JSON, now it looks all pretty. And this is the actual event for that API, for that tag change, which is one of the things that we have set up as triggers for our Lambda function. So the test event is there, and I will click save. Now, I don't want to test yet because we haven't actually put the new Lambda function in place, and we need to do that. So let's go to code. And within code, we're just going to replace everything. So if you remember, our original Lambda function just logs everything. So it just says, hey, let's go ahead and log the entire event. That's all that this particular Lambda function is doing. The one you want to replace it with is in the blog post. And I've got that preloaded onto in my text editor here. So I'm going to copy the entire thing out. And again, in your case, you will copy it all out from the blog post. There's no changes needed in the code because we have everything set to work off of variables. I'm going to do Command A to select everything and Command V or Control A, Control V, whatever. I'm on a Mac. You're allowed to be on Windows. And we put everything in place. So this is the updated code. And I do encourage you to go ahead and look at the code. For today's lab, I'm not going to spend much time on it. You'll actually see, though, we're going to kind of bounce into that in a minute. So the code's there, and it's all ready to go. And I want to replace my existing code. So I will click deploy. So that's deploying that function. The function is up and running. Now we have our test event and we have our code. So let's see what that looks like. I'm going to close these two green boxes here just to get them out of the way. And I'm going to click test. And you can see the output of the test down here. Now, at this point, I have a test succeeded. You probably have a test failed. And why is that? Because this takes more than 3 seconds to run, which is the default for a Lambda function. What I want you to do is go into configuration. And remember, Lambda functions will time out after a certain period of time. So we'll scroll down here, and I have to remember where this is. I think it's under general configuration. I set my timeout for 30 seconds, and I'm going to go in, and normally it is 3 seconds, and I'm going to save that. Why? Because I have to get the screenshot for the blog post. So if it's at 3 seconds here, and I actually go to run my test again, so I'll go back to code, and I run my test, I'll get a straight up error message. And it says sandbox timed out. So let me scroll down. It's a little hard. And if you get that error, which you will get, just go to configuration, edit, change this to 30 seconds, and that is more than enough time, and click save. So then we go back to test. We have our error there. Or sorry, we go back to code, and we'll test it again, and we'll see what our results are. This time it looks like it's working, and we do have results. Let's scroll down and just look through. So this succeeded because it didn't crash. However, as part of testing, remember, we have error handling that I built into that code. And if I scroll down and look at everything going down here, okay, a little clip because I was having trouble finding my error message. But if you scroll down, you'll notice here we have a warning. And that warning, this is in our logs, error getting bucket ownership. An error occurred, access denied, when calling the bucket ownership controls. Because no identity-based policy allows the API call get bucket ownership controls. Now, why is that? Well, if we look at the stack set, so we need to take a look at the permissions. So clearly we don't have permission for one API call, but our other API calls worked. And this is all part of error handling and basically debugging your code. So this is a pretty clear message. The policy does not allow that particular API call. Well, that's a pickle because remember, this IAM policy is deployed out in our target account, which is that production 1 account, because that's the account ID that we actually pulled from the event, from our test event. So even though we're using a test event, all of this code says still try and do everything. So just be careful about that. It's not testing it in a vacuum. It's still connecting into that account. Well, how do I figure this out? Here's how I handled this when I first ran into this error as I was developing the lab. I'm going to go up here. I'm going to right-click service. Whoops. I'm going to right-click the little AWS icon and open link in a new tab. This is going to give me a second tab where I can bounce around the console. And I'm going to go into CloudFormation. And we pushed out that permission policy from stack sets. We're going to go to stack sets, service managed. And the policy, if you remember, was that auto remediation role. That's the policy that our Lambda function is assuming. Now, this is cool because what I glossed over a bit is we talked about our role chaining in the code, and I went through all of that. The assume role function up here, which gets called in the main body of the code as kind of one of the first things that it does. Yep. So, oops, it's hard to find it as I'm bouncing around the code here, but that assume role function actually worked. So we are touching that account, but if I go into the permissions for that account, so let's go into that auto remediation role, and we can actually review the template right here. This is what we pushed into that account, and we look at the permissions. And we are missing that get bucket ownership permission. It's just not in here. So we did not set that up. Now, why is that one important? That particular one is what allows us to figure out if ACLs are enabled. And that's one of the things that we care about because ACLs are a way of externally exposing content. And we talked about all of that. And I know you lost it because we've been doing this over the course of like 2 months at this point. But if you look at the earlier post, we do need to know if those ACLs are in place. So we need to add that permission. All we need to do is add that to our CloudFormation template. Now, to make your lives easier, I created a new template, and now we're just going to go ahead and update the stack set with the new one, and that's going to add that permission in place. Why did I do this as a new template? Why didn't I just update the old template? Because some people won't hit this lab for a year, and I want it to behave the same. So I don't fix the old one. I actually replace it with a new one. And there might be reasons you do this in your real environment, but that's why I'm doing it here. It's so that we actually learn this debugging process, and everybody who watches this video and everybody who follows along with this lab will get the same error message. Okay, so let's go back in, and we want to update that. So if I go back to my stack set info here, we're going to replace it with the new template. Now there's one thing we need. There's going to be actually two things we need. The first thing we're going to need is our OU. So I'm going to copy that, or because this is the OU we're going to push it into. And unfortunately, there's not just like a simple deploy this back to the OU where it came from. We actually have to write that down. And so I'm going to just put that here so that I have it, and we'll go back over. Then I go to Actions, Edit Stack Set Details. We're going to leave our service managed permissions, and we are switching the template. So we're going to replace the template with the URL from the blog post. And let me go ahead and grab that URL. Okay, I copied that out of the blog post, and let me paste that in. And you'll see it says Lab 55. That's the new version. The rest goes pretty quickly. I'm going to click Next. We're not changing anything here. Our parameters, everything stays the same. We click Next. We're not going to add any tags. We do need to say it's going to create IAM resources with custom names. And we click Next. And we have to put in our OU ID. So that is the one that I copied to the clipboard. And let me pause and get that back. We'll paste in that OU. And we just do add all regions. And we know this is only going to deploy to like a couple of accounts. I'll leave my deployment options the same. Click Next. Scroll all the way down and click Submit. Now this is updating the stack set, which is now going to replace that policy and add our new permission. It's going to basically update everything on the other side. It does take about 1 to 2 minutes. I'll pause the video while that happens. I hit the refresh button. That succeeded. So the stack is deployed and we've updated. So what is different? If I go look at the template and I scroll down, you can see we added the permission for get bucket ownership controls. That's now in place. Let's go back over to my Lambda function screen, and I'm going to click test. And so it's taking that test event. Did I not click it? Whoops, got to scroll down, just getting everything on screen. There we go. So it says it succeeded, and we're going to look down at the results. And you notice I have my info, all my logging info. Awesome. So it did not give any errors. And the end result now is results. And let me try to zoom in a little bit here, is that we now have the bucket name, the ARN for the bucket, the account ID, any of the current tags on the bucket, what the bucket policy is. If it has one, it does not have a bucket policy, so there's no results there. If ACLs are enabled, we actually disabled that by default, and public ACLs, and if a block public access is turned on. So all of the things that we're going to need in our decision making. And to finish this up, because that's actually it for the lab. There's nothing else to fix here. And as a quick review, we created a test event. We built that test event into the AWS console so that we can go ahead and run changes. We updated our code, and I'm going to do a really quick walkthrough of some of the pieces of that code, just so you know what's going on. We tested it. It didn't work. Oh, why didn't it work? Because we had to adjust our configuration because of our timeout. Okay, we tested it again. Did it work? Oh, it didn't work because we did not have the proper permissions. We jumped over into CloudFormation. We pushed out that permission that we needed. That fixed that problem, and now this code runs completely. Now, what does this code do? Very quick review, because we will get into this more later. But there's a couple of functions. And I know not all of you are programmers, which is why I just do copy and paste for this code, but you should have an understanding of it. I went through in detail how this whole assuming role piece works. So that function is hanging out there, waiting to be called. The next thing we have to do is we have the event coming in. And remember, that event, in our case, we are using the test event, which is the JSON from the CloudTrail log of, in this case, of changing the tag of a bucket. We're not trying to figure out what happened based on the event. I actually don't really care about the event. I care about what does the bucket look like now. But we got that event, and that event has a couple of important things in it. One, what account where was this change made? That's really important because we don't know where to look so that we can update our information and figure out how is that bucket configured. And then the next thing is, which S3 bucket is it? And that's down here. It can be in different places within the different events. And you'll see as I switch back over to the code, the extract bucket name, we look in 3 different areas. Is it in the resources array? Is it in the request? Or is it in the response? Like if you create a new bucket, actually with buckets, it would show up in all areas. But this checks all 3 areas where we might have a name. So that's all this function does is take the event that was passed in and find the bucket name. Then this one pulls the bucket information. We actually get the account in a different place. I'll show you where that is. And what information do we care about? Well, these are the pieces that we care about. Is block public access turned on? Are the ACLs enabled? Is there a bucket policy? How is it tagged? What's the account ID? All of those things which we will actually use to do our auto remediation. So then we pull the tags, and there's some API calls to pull the tags. We pull the bucket policy if it exists, and there's the API calls to pull that. And then we get let's find the ACLs, and we need to know are ACLs even turned on, which is that ownership control piece. And I'm not going to go into the details of that. We've covered that previously. And honestly, I'd confuse myself talking too much about that. And the block public access settings. That's all the security stuff we want to know that will tell us if this bucket is shared publicly. And then we get into the Lambda handler. When the Lambda function runs, this is what's called. It's all of this stuff in here. And so it says, hey, I'm processing an event. Let's pull the account ID from the event. So we're going to use that so we know what account to assume our role into. Then let's assume a role into that account. So it's going to call that function up above and swap in that account ID. And it's going to use that in combination with the ARN of our auto remediation role. Then some things about, depending on how the events comes in, let's get the bucket name, depending on where it is. And then we'll use that to call the get bucket information, which is all the information, the tags, and everything else in the status. I know I went through that quickly. If you want to understand the ins and outs of the code itself, you can spend time with that. I am actually, after we finish this entire sequence, I'm also going to be doing a S.L.A.W Pro video for Pro subscribers so that we'll walk through it in more detail and answer all the questions in a live session with that one. But as a review for today, we now know how to assume a role and do role chaining in code. And we start with, again, our baseline Lambda execution role. We use that to assume the role in the target account. And then that gives us our temporary credentials. And then our code uses those temporary credentials with all the API calls to jump into that account and extract the information about that particular bucket. And we learned how to create a test event. And then we actually learned how to run a test. And we did some very basic debugging. I left in 2 errors for us to fix. And those were both quick and easy to fix. That's it. Have a great week.